Hello everybody, this is Priyadarshini. Now I'm going to explain the Varignon theorem from Unit 3 Forces on a Rigid Body. The Varignon theorem states that the sum of the moments of two intersecting or parallel forces about any point is equal to the moment of the resultant of the forces about the same point. So now I'm going to prove this theorem in two cases. First, I take intersecting forces. Let us consider the diagram. Let F1 vector and F2 vector be the lines of action of forces which intersect at A. Then the moments of F1 and F2 about O are OA vector cross F1 vector and OA vector cross F2 vector. According to the statement, we need to sum the moments of two forces. So now we get OA vector cross F1 plus F2 vector. Mark this as equation 1. We know the resultant is F1 plus F2 vector for F1 vector and F2 vector. Now taking the moment for this resultant which is acting at A about O is OA vector cross F1 plus F2 vector. Mark this as equation 2. Let us look at the equation 1 and equation 2. From these equations we can conclude the theorem follows for the intersecting forces. That is, the sum of the moments of two intersecting forces about any point is equal to the moment of the resultant of the forces about the same point. Let us look at the case 2 for parallel forces. Consider this diagram. F1 vector and F2 vector be the forces, be the parallel forces, and F1 vector is equal to F1 I vector and F2 vector is equal to F2 I vector. I vector is nothing but direction which is acting at A1 and A2. Let small a1 vector and small a2 vector be the position vectors of A1 and A2 with respect to the point O. Then their moment is A1 small a1 vector cross F1 I vector and small a2 vector cross F2 I vector. Similarly, doing the same according to the statement, we need to find the sum. And their sum is F1 small a1 vector plus F2 small a2 vector cross I vector. Mark this as equation 1. Now, the resultant of F1 I vector and F2 I vector is F1 plus F2 I vector, which is acting at X. So let us see the diagram once again. So the resultant, that is F1 plus F2 into I vector, which is acting at the point X, where X divides this A1 and A2 internally in the ratio of F2 is to F1. So now we need to find the position vector for X. So the position vector of X is OX vector is equal to F1 small a1 vector plus F2 small a2 vector divided by F1 plus F2. Mark this as equation 2. So the moment of the resultant about O is, according to the statement, we need to find the resultant for same point. So we get this as OX vector cross F1 plus F2 I vector. Mark it as equation 3. Now substitute the equation 2 in equation 3, that is substitute the position vector of X in 3. We get F1 small a1 vector plus F2 small a2 vector divided by F1 plus F2 cross F1 plus F2 I vector. Cancel the F1 plus F2 and F1 plus F2. We get F1 small a1 vector plus F2 small a2 vector cross I vector. Mark this as equation 4. Let us see the equation 1 for the sum of the moments of forces and the moment of resultant of forces. From the equation 1 and 4, we get the theorem for parallel forces. That is, the sum of the moments of two parallel forces about any point is equal to the moment of the resultant of forces about the same point. Hence, the Varignon theorem is proved. Thank you.